one day at
Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's live, we're just going to be going through a few questions for some last minute paper 2 revision. It's not a past paper, but it is basically past paper questions that I've kind of picked and chosen. So it's not a whole paper, but I have picked a few different questions that are on topics that I think are kind of the ones that we should be revising tonight. So we're just going to go through a few of those. They're going to start off a little bit easier and then it will kind of work up to the harder ones at the end. But I'll show you now the topics that we're going to cover. It's just a quick kind of last minute revision one. So you can see here, we've got some error intervals, a bit of compound interest, recognizing graphs, some area and volume, iteration, upper and lower bounds, and sine and cosine rules. So you can see, yeah, it will probably go from, I would say about, 5, maybe grade 5 to 8. As you can see, we're starting off with easier ones and then working up to the harder questions. Yeah. So let's just go through. So this is based on what I've seen from paper 2s from Edexcel, basically. So this is quite niche to Edexcel, obviously for higher tier as well. So the topics I think have kind of repeated themselves quite a lot. So those are the ones I think to focus on, just for, I don't know, maybe 45 minutes, an hour or so. So question 3, a number m is rounded to 1 decimal place. The result is 9.4. Complete the error interval for m. So error intervals is a really, really nice question because it's 2 marks just for writing 2 numbers. You don't even need to really write any working out down. When will the stream end? For however long it takes me to get through the questions, I would assume probably no longer than an hour, maybe 45 minutes. So yeah, so this one, because it's rounded, so you've got 2 different types of error intervals questions, right? And as long as you know how to answer both types, then you're set. So this is the first type. I have got a question after this on the second type. The first type is when it's been rounded to something. So rounded to 1 decimal place in this case. Maybe they say correct to the nearest meter or something. You know, like that when they've obviously rounded it. Anything like that, it's effectively the same as upper and lower bounds. So you want to have a little bit less and a little bit more. So in this case, because we're looking at the 1 decimal place, you want whatever they've rounded it to, you want half less and half more. So that's technically 1 decimal place is 0.1, isn't it? So half would be 0.05. So I know I'm kind of over explaining it. Some of you are just going to look at it and go, yeah, I know exactly what the answer is. But that's what you would do and just apply, depending on what they've rounded it to, just half it, add it on, take it away. So yeah, we should have 9.35 because that's a little bit less, isn't it? That would round up to 9.4. And then the biggest would be 9.45 because not literally 9.45, but anything slightly less than that would round down still, wouldn't it? So those would be your 2 marks. You get 1 mark for each number, obviously, and also it has to be obviously in this correct order. So the smallest one is always on the left. This is not a predicted paper, no, but I have got one which is uploaded on my channel as a video. You can look at that if you like. Did I make this paper? No, this isn't a paper, this is just paper 2 topics from Edexcel. So we've got question 9. Martin truncates the number n to 1 digit. The result is 7. Write down the error interval for n. So this is obviously the different version, right? This is a different version. So this isn't rounded, and I think also, because you might not have even seen the word truncate before. Truncate is just where they've cut off all the digits, right? So they looked at it, so Martin looked at it, he saw a 7, so there definitely was a 7, it definitely started with 7, but then he just didn't read what came after it. So when you've got a scenario where it's truncated, the smallest number is just the number they've given you, so that's fairly straightforward. So 7, you obviously in this case have to put your own inequalities. And then the biggest number is technically 8. Now, I know it can't exactly be 8, but do you see my inequality symbol? It's saying less than 8. It's not equal to 8. it's less than 8, right? Because it could have been 7.99999. We don't know, because all Martin did was look at the first digit and then he cut off the rest. He ignored it. So it could have been 7.0 or it could have been 7.9999999, right? It could have been either of those two. So for truncating, that's the difference, right? Different to upper and lower bounds with the first one. There's also a scenario where sometimes they write down that this person was looking at their calculator display. You know, it says about the calculator. They read off the first 2 digits. Exactly the same thing. It's the same concept as truncating. So if you see this, or you see the one where it says something about they've read off their calculator display, exactly the same. Okay, so the smallest number is the number they've given you if they've truncated it. Okay, and I used n because they gave me n, right? So the number n was between 7 and 8. And again, 2 marks for those numbers. So that was basically error intervals. Compound interest, we've got, for this question, Louise invests X pounds in better investments for 3 years. Sadiq invests X pounds in County Bank for 3 years. So they're both investing the same amount of money, right? And they're both investing for 3 years. The difference is that Louise is going with better investments, which is compound interest 2.5% per annum, whereas Sadiq is going with County Bank, which is obviously also compound interest, but it's a split one. So we've got 2% per annum for the first 2 years, and then we've got 3.5% per annum for each extra year. At the end of the 3 years, the value of Louise's investment is £344,605. Work out the value of Sadiq's investment. So I chose this one because it's got a few different elements to it, a few different kind of types of questions they could ask. They've asked it all in one question here. So for Louise, we're going to have to use her information in order to find out the initial amount, the original amount they both have, wasn't it? So you want to use your formula form if you've obviously memorized it, or it's on the formula sheet. So we've got for Louise, we don't know how much she started with, so we'll just put the X. Multiply that by the 1 plus the 2.5%. So I like to write it like this. You might like to write it in the same format as your formula sheet. That's also fine. Same thing. And Louise invested for 3 years, so to the power of 3. Now I can write that that's equal to the 344,000. That's what it's equal to, isn't it? So all I need to do is just rearrange this, isn't it? So we've just basically got an equation. I want to get x on its own. So all I'm going to do is move the 1.025 to the power of 3 across, which means divide, doesn't it, if you think about just normal equations. So divide it by 1.025 to the power of 3. And then you get this number here. Now, this is quite a nice round number, isn't it? This is quite a nice rounded number. So you think, yeah, that probably makes sense, to be fair. Because I doubt that Louise was, based on the question, I don't think they were going to just put a random number as their investment. So yeah, that makes sense. For 9, do you do... No, you don't put less than or equal to 9. Do you see what I did? I put 8. You don't put 9 recurring, because the 8 accounts for the 9 recurring, okay? But it's not equal to 8. So the 1.025 is, so from your formula sheet, you take the initial amount, or the principal amount, I think they call it, you multiply it by, into your bracket, don't you, 1 plus the percentage over 100, which was 2.5, wasn't it, because we're doing Louise, and then to the power of 3. That's from the formula sheet if you want to copy the exact thing from the formula sheet. Okay, so I just did it like that. That's the same thing, isn't it? 1 plus 2.5 over 100 is the same as 1.025. So same thing, right? So that's where that's come from. So I've obviously just reversed the formula. That's one thing they could ask you. Now that I know how much the initial investment was for Louise, it's obviously the same for Sadiq, isn't it? So that's fine. So now I can move on to Sadiq because I now know what he was investing initially. Now for Sadiq, we're kind of working in the correct direction, but he has got a split interest rate. So we're starting out with our £320,000, timesing it by, and again, using that formula, 1.02, well, that's the same as 1 plus 2 over 100. Now, that's only for 2 years, though. So let's just work out the first 2 years. You can do it all in one step, but I'm just going to work it out separately just so you can see. 1.02, and that's only for 2 years. So after 2 years, Sadiq has this amount, 3,000, I can't even read it, 332,928, there we go, 332,928 pounds. That's after 2 years, but obviously we want to work out 3 years. So we're going to take this as our new initial amount, our principal amount, and we're going to apply the 3.5%, but that's only for 1 year, isn't it? So 1 plus 3.5% basically, to the power of 1, but obviously that's just the same, isn't it? So take your answer, times it by this. We've got £344,580, 48p. Right here, 344,580 and 48. I tend to leave it to 2 decimal places just because it's money. Yes, you're right. Is it that? I'm just checking the comments. This is not foundation. No. Oh yeah, it says paper 2H in the title. So that would be your answer. I guess you could round it, but I would just leave it to 2 decimal places because I think because it's money, that makes sense, doesn't it? So that's how you do not only reversing compound interest if you need to, and also split interest rate. So obviously that's a bigger question. Hopefully yours will just be kind of one or the other. How do we know Sadiq started with 320,000? Because do you see how they both started with X? That's X represents the same number. If it wasn't the same number, they would have to use a different letter. And we worked out that Louise, because we used Louise's information to work out X, it was 320,000. And if Louise is 320,000, then Sadiq is also, because they're both X, and X is 320,000. Okay, so that's a little bit of compound interest. I've seen a lot of recognizing graphs come up in paper 2s, maybe even paper 3s. This is obviously the biggest question with 9 graphs. Sometimes it's only just 4 graphs, sometimes it's 6 graphs. I thought I'd just go with the one that had the biggest amount of graphs for us to look at. Exponential increase. Not explicitly, you need to know, relating to this, you need to know what an exponential graph looks like. But yeah, so just memorizing the graphs I think is a really nice question. So obviously here we've got some graphs in the table below. Match each question with the letter of its graph. So we've got 4 here. So it's a little bit harder because there's actually obviously 9. Sometimes they give you 4 in the table and 4 on the actual sheet. So you can just obviously use process of elimination. In this case, you actually have to obviously know what you're talking about. So the first one, y equals sine x. We're looking for a trigonometric graph, the sine graph specifically. We've got C and D. And I think they've done this deliberately, is they've given you 2 graphs that you think, yeah, those are, one of them is sine, one's cosine, but do you remember which is which? Sine always starts at 0, 0, 0. So that's how I remember it. So this one is the sine graph. So that would be C. This one is therefore the cosine graph, because this is technically 1. It always starts, it's the same shape, but it starts at 1 on the y-axis. The sine graph starts at just 0. So that's how I remember it. They're both the same except one starts at 0, one starts at 1. So that's the cos graph. Then we've got a cubic graph. So having a look here, do we have any that look like cubics? Actually, luckily, there's only one that looks like a cubic graph, isn't it? So that would have to be F. There's only one there. That's a cubic graph, positive cubic one. You also have to recognize if it's negative as well, so don't forget that. A negative one would be like the opposite way. That would be negative x cubed. Then the third one, this is the exponential graph, isn't it? Something to the power of x. So we have actually got 2 that look like an exponential graph, or 2 that are exponential graphs. You see we've got A and we've got I. So again, you need to know not just roughly what it looks like, but more specifically, is it A or is it I? Well, because it's a 2, it's this one. Let's put k to the power of x. So k could be any number, obviously. It's this one. This is where k is greater than 1. The one here is the same. It's still an exponential graph, but this is where k is between 0 and 1. So like maybe 0.5 or something. It goes down instead of up. Okay. Oh yeah, the one about rabbits. The one about rabbits is basically iteration. I would class that as iteration. I guess it's the same concept, but I would in my head class that as an iteration question. So, and then the last one is a reciprocal one, isn't it? So again, we've got two B and H that look like a reciprocal graph. So you have to figure out, well, actually, which one is it? Because this one has got 4, positive number, it's going to be H. Yeah. So this is y equals, when I say k, it just represents a number, right? Any number. So you could sub in any number there. And then this one is your negative one. So like if k was a negative. The last two, which are obviously not part of this question, but this is an x squared, sorry, a quadratic, and then this is a negative quadratic, isn't it? It's like an N shape. So there are your 9 graphs. Yeah, exactly. The last one, which is reciprocal, is also a proportion, an inverse proportion graph. So sometimes they ask about proportion. That's an inverse proportion graph as well. Inverse proportion. Direct proportion is just a straight line. Like this. Is a linear one, you know, y equals mx plus c. And this one is inverse proportion. So if they ask proportions, those are the two. Direct is just straight line going up. And then inverse is the reciprocal, but the normal reciprocal. Obviously, you also need to know the tan graph, but apart from that, I think that covers the majority of the graphs that you would need to know. Yeah. How would you know if the question is asking about trigonometry, area of a triangle, or normal area of a triangle? Because whenever I see area of a triangle, you just basically, the way that you would know whether to use the normal area of a triangle or the trig one is if you have the perpendicular height. Some questions you will have that, and you can just go straight ahead, base times height over 2. If you do not have the perpendicular height, and you do maybe have some angles, you have 2 sides, that's when it's area, the trig one. Yeah. It should fit into one or the other. It should be quite obvious. Well, exact trig values coming up is fine because you'll have a calculator, so you can just put it in the calculator. Question 12. I think there's quite a lot on sectors. Maybe arc length, maybe area of a sector, maybe the segment, you know, when you draw a line across here. That kind of thing. I think that comes up quite a lot. So we've got OAB as a sector of a circle with centre O and radius 7 centimetres. The area of the sector is 40 centimetres squared. Calculate the perimeter of the sector. So we need to use the area to work backwards because we don't have an angle, do we? We need to know that. So you would need to know this formula. You have got kind of half of it on your formula sheet. You've obviously got area of a circle and you've got circumference of a circle on the formula sheet anyway. But to make it just a sector, so a smaller amount of the whole circle, we would need to do, obviously, the area is obviously pi r squared, but you then times it by the angle. I'm just going to use theta to represent the angle. You could use x if you want. This angle here over 360, because it's kind of like showing you a smaller proportion of the whole circle. A whole circle is obviously 360 degrees at the point at the center, isn't it? So I think that makes logical sense. Anyway, so here I can set this up and write, I actually know what the radius is, which is 7, isn't it? So I've got pi times 7 squared. I don't know the angle, but I do know the answer is 40. So I'm setting up an equation. And now all we need to do is just rearrange this, because the only thing that I can do is find out the angle, isn't it? There's nothing else I can do. So grab my calculator. Now you can do this in as many steps as you want. You can do it all in one step. I'm just going to, I'll probably divide in I'll probably do 2 steps just to show you, but you could do it in 1 step. So we're going to move things obviously across to the right hand side of the equation. So let's just divide first by 7 squared times pi, which is 49 pi, isn't it? 49 pi. And then you would have to times by 360, wouldn't you? Because that's already divided. So times by 360. So you get 93.544. So that's the angle. Try and keep as many decimals as you can, because this isn't the final answer, is it? What did I say? 5. That's a horrible 5. Let's do that again. 544. So I'm keeping a couple of the decimals there. So this is now this angle. So I've dealt with that. I can move on from that. Now let's think about the perimeter. The perimeter is more specific than just the arc length. Obviously you've got the arc length, but the perimeter is when you add all of the sides together, which we've got 3. We've got a radius, another radius, and the arc length. So obviously I need to find the arc length, which is basically the same formula, obviously not pi r squared. It's now, you might want to use 2 pi r, you might want to use pi times diameter, it doesn't matter. The circumference basically, but multiplied by the same fraction, because again, it's a smaller portion of the whole circle. So I can sub in everything that I know here. I know the radius is 7. And now, this is why I wanted to work out the angle, wasn't it? Because now I know the angle as well. 93.5. Obviously, I'm going to use, I'll get my calculator again. I'm going to use the whole of this answer. I'm just not writing down maybe all of the decimals. So 2 times pi times 7 times, and then I'm going to use my answer button. Do you see I'm using the answer button? That will copy, as long as it is your previous answer, which it was your previous answer. In this case, the previous answer was obviously my angle, so that's good. So I get another really kind of annoying number, 11.428 maybe. Let's just write down a few decimals again because we're still not quite at the end. 11.428. Now that's the arc length. And as I said, the perimeter is that's one of the sides, plus a radius plus another radius. So just don't forget at the end, if it asks for perimeter, to add on the other two, because I feel like it can be quite easy to think that this is just the answer. So again, I'm using my answer button, plus 7. Now that this is my final answer, I'm now going to round it. So now I can have a look, and it says 3 significant figures, so that would be 25.4. 25.4. So again, a kind of a mixture of things here, reversing and undoing an equation to work out the angle, so we're going backwards, then working out the arc length as well, so you've seen all of this. Yep, 25.4. Just remember it is 3 significant figures, so you don't need the 3. But yeah, you are right. Okay. Yeah. I mean, they don't penalise you, actually. In Edexcel, they don't penalise you if you round it wrong. As long as your answer is obviously, you know, still the correct number. If you round it incorrectly, they don't tend to mark you down, but obviously do try to round it correctly. Most of the time, they will give you some version of how to round it. Okay. Just having a look at the comments. Algebraic proof, histograms, functions, converting decimals to fractions. The things you've listed all came up on paper 1, so I doubt they would come up again, to be honest, if I was to guess. You didn't understand why I did 7 plus 7? Because the perimeter, let me get a highlighter, the perimeter is all of the sides, isn't it? Added together. Do you see how I've got a 7 here for the radius, a 7 here for the radius, and then this was the 11? So to find the perimeter, this is the 11, isn't it? 11.4. To find the perimeter, you add up all of the sides. 7, 7, and 11.4. Why 7 squared, not 14? Up here, because this was the area. This one was the area. Let me redo that arrow. So that one was 7 squared. This one here is 14, isn't it? That's the arc length. So yeah, there is a 14. It's just I didn't write 14. I wrote 2 times 7, which is 14. Yep. Yeah, okay. Yep, just seeing. It's not that it 100% won't come up, the histograms, but I feel like, if I were to guess, I feel like it's less likely. I don't know. Obviously, I've not seen the paper, right? How would I have seen the paper? I don't know. But because histograms came up in paper 1, I don't know why they would ask it again. They might. Look, you can never say never, right? I'm not saying that it's 100% no, but I'm saying that there's maybe less of a chance. Because think about how big the syllabus is. They've only got 3 papers. They want to try and test you on as much as possible. So why would they repeat something as specific as histograms? Obviously, things like probability, that's quite vague. So they could repeat that millions of times. Ratio, they repeat that loads of times. But for histograms, I feel like it's quite specific. As I said, I'm not saying that it won't come up. I'm not saying that, so don't just completely kind of ignore it. But I'm saying that maybe it's less likely. Yeah, they've done a weird thing this year, so I mean, who actually knows what they're going to do? Okay. Yeah, it's still possible to get a 7, definitely. Yep, it is still possible. Obviously, just might be harder, but it's not impossible, I don't think. Even if you've got 0, it's not impossible, but I'm assuming you've got more than 0, so that's fine. So question 9, I'm saying I don't know if we're not getting any more histograms. I'm not saying it's not going to come up. I'm just saying it maybe there's less of a chance. So yeah, don't come at me if it doesn't come up again, because I'm just saying it's less likely. Doesn't mean it's impossible though. They could do whatever they want ultimately, can't they? Question 9. So obviously volume, area, again, all of that kind of stuff comes up a lot. You didn't have any trig, I don't think, in paper 1, so that's also going to come up. So I've got one here where I've got a bit of a combination of the two. So we've obviously got here a prism. We've got the cross section of the prism has exactly one line of symmetry. Work out the volume of the prism. So it's effectively a compound shape. You've got this triangular prism and then a cuboid, haven't you? So you could always work out the cuboid first, even if you weren't sure how to do the triangular one, for example. You still get some marks. This is 5 marks ultimately. So we might as well, yeah, let's just do the cuboid first. So volume of the cuboid. They've given you on your formula sheet the volume of a prism kind of generally. So you just have to apply it to the correct shape. Obviously, in terms of a cuboid, it's just all of the sides multiplied together, isn't it? That's kind of easier. So 12 times 10 times 20. You might as well get the marks for that, even if you're not sure about the triangular bit. 12 times 10 times 20. 2,400. Obviously, that's centimeters cubed, so we'll just leave that there for now. Now let's focus on the triangular prism. Obviously, prisms, you have to work out the area of the cross section, which is this triangle here, isn't it? Then you times it by the length, which is 20. So I need to work out the area of a triangle. Now, I've got the base of the triangle, technically is 10, isn't it? Same as that 10 down there. But I'd need to know the height. Because this is only question 9, that's also why I'm thinking it's probably not area using trig. If that makes sense. Well, how do I explain it? It's not the trigonometric area formula, the half AB sine C, because it's question 9. I don't think it would be that. You could probably work that out. You could do it that way, but there is another way to do it. So because they told us that there's one line of symmetry, that means, it's obviously down the middle, isn't it, if you think about it, that I can split this, and I know that that's exactly half, so it's an isosceles triangle. So that's a 90-degree angle. So I've created here just a right angle. Yeah. I've created here a right angle. And so because I want to use my normal formula, you could use half AB sine C. You could work out this side here, the hypotenuse, if you wanted, but I'm just going to work out the perpendicular height, which is the dotted line I've shown. So now, obviously, looking at this triangle, this right angle triangle is now half, isn't it? So that's actually a base of 5 because it's only half of the whole triangle. And then I want to know the opposite because it's opposite the angle. I've got the adjacent, so that's tan. Tan, I like to use my formula triangle. Because I'm looking for the opposite, I have to do tan of 40 times by the adjacent, which is 5. So this is just normal trig, isn't it? Which, as we said, they haven't asked you yet, I don't think. So, you know, good chance that some version of this will come up. Times 5. 4.195, again, loads of decimals, just going to write down a couple of them. So the perpendicular height is 4.195. So now I can just do the area of a triangle, which is base times height over 2. So now I know the base of the smaller triangle is 5. I'm going to do the whole thing, right? The whole triangle, right? So I'm focusing on the whole thing, which was the base was 10, wasn't it? Times the height, which is 4.195 over 2. So get your calculator out. I'm going to copy my answer. So 10 times answer, just so I get all the decimals, because again, we're not right at the end yet. So the area of the triangle is 20.977 centimeters squared. And now to make it into the volume, we have to multiply it by the length, don't we? So the volume, and that's a triangle, but you know what I mean, triangular prism, is the 20.977 times by the other 20 that I haven't technically used yet. Times by 20, so 419.55 maybe, 419.55. Now that's then the volume. So final thing, add up my two volumes because it's a compound shape, isn't it? So the total volume, 2,400 plus 419 is 2,819.55. and now I can round it. It says 3 significant figures, so as you said in the comments, 2,820. This topic is volume and also trigonometry. Let me just have a look at the comments now. Yeah, this isn't A-level. This is GCSE. Hence why my channel is called GCSE Maths. Okay, just checking the comments. Um, 3D trigonometry. Yeah, okay. Yeah, okay, no questions. Yeah, okay, perfect. Gonna move on. So now, I mean, this one's a fairly straightforward one. The only reason why I kind of threw it in there is because I don't think you've had either spheres, hemispheres, or cones yet. I feel like that's normally a paper 1 topic, but it hasn't come up. So I've thrown it in. As you can see, they will give you the correct formula that you need, whether it's for volume or whether it's for the surface area of a sphere or a cone, because they're not prisms, are they now? This is no longer a prism. But I just wanted to point out, because I know it's only 2 marks, but I feel like we can easily make some mistakes here. It is just subbing into the formula, isn't it, basically? But there's 2 things to be aware of. The first thing is that the diagram shows a hemisphere with diameter 8.4. Edexcel will always give you formulas for sphere or cone with radius. So you have to remember, I normally almost immediately just label it with 4.2. That's half, isn't it? The radius is 4.2. Just to remind me, don't use 8.4. Yeah, I don't really know how this is question 19, to be fair. But yeah, don't use 8.4. It can be so easy just to sub in the 8.4 and not think about it. The second thing is, they've said obviously work out the volume of the hemisphere, but they will only ever give you the volume of a sphere as the formula. Hemisphere is obviously half. So you need to remember to also half your whole formula. As long as you remember those 2 key things, then it's just subbing it in, isn't it? So 4/3 pi times the radius cubed. As I said, 4.2, not 8.4. And then all of that over 2. Just remember those 2 details. A lot of the time they give you a diameter. Again, also with cones as well. A lot of the time they will give you a diameter to trip you up. They will also give you the formula for the whole thing, when in this case it's only half. So just make sure you're reading the question properly, because you don't want to lose marks on this one. It's so nice otherwise, isn't it? 4.2 cubed, and then half of that, because we want half of the volume of a sphere. So that's 155.196, 169 even, and then 3 significant figures, 155. The other thing to note, this is volume obviously, but when you have the surface area, which they will give you the formula for the surface area of a sphere, but if you had a hemisphere, obviously remember to half it, because it's only half of the whole sphere, but also the surface area of a sphere also includes, because surface area is when you add all of the sides together, isn't it? This one, which is obviously not in the formula. You just have to, well, I guess it's on your formula sheet because it's area of a circle, but you'd have to remember for the surface area of a hemisphere, take the formula they give you for the sphere, divide it by 2, but then make sure you remember to add on the other circle, because they won't put that in the formula. So things like that, just kind of pay attention to what formula they've given you and what you also have in your question. Yeah, okay. That's fine, yeah. They've asked you to put units. Sometimes, not often, but sometimes, yeah. Not very often, though. Okay, iteration. I know someone asked for iteration. This is obviously a big calculator kind of question, because it's normally loads of decimals. So I've chosen one. It's not the one that's got a scenario, but it's one where we've got just all 3 parts. So just in case they ask you different things, this is all 3 parts. So part A, show that the equation x cubed plus 7x minus 5 equals 0 has a solution between x is 0 and x is 1. Really easy 2 marks. You just have to remember what to do. All you need to do is substitute in both numbers. Whatever numbers they give you, sub them in. So, oh, that's still my highlighter. So for x being 0, seems kind of pointless to write it down, but just do it for the working out marks. So 0 cubed plus 7 times 0 minus 5. Like, show them that you have subbed it in. Obviously, I know that's going to then give you just minus 5, isn't it? Then you've got x is 1. Do the same. 1 cubed plus 7 times 1 minus 5. And then work that out. So that, I think, gives you 3. That's normally 1 mark. That would give you 1 mark. You do have to then kind of say what that means. Now, because this number here was 0 at the end, you see how I've got one answer that's below 0, one answer that's above 0. So yes, in this case it is sign change. Sometimes there's a number here that, like 4. Either you then rearrange it to make it 0 and then look for a sign change, as you've said, 1 negative, 1 positive, or you just sub it in and get one answer that's above 4, one answer that's below 4. That's kind of the logic. So if you've got a number at the end where it's equal to not 0, I would probably just rearrange it to make it equal to 0 as well, and then you can say sign change. So you say sign change or negative positive, you know, some version of commenting on the fact that you've got a negative and a positive. Therefore, and then you just copy whatever they've said in the sentence, in the question. Solution between, in this case, 0 and 1. That's your second mark. X is 0 and x is 1. Yeah. Yeah, just having a look at the comments. There is a sign change. Exactly. You're mentioning the sign change. Yep, substituting 0, substituting 1, mention the sign change. Yeah. Part B is then show that the equation x cubed plus 7x minus 5 equals 0 can be rearranged, or, well, I guess can be arranged to give x is equal to 5 over x squared plus 7. So again, 2 marks. You just have to figure out, just look at both of them and go, right, how have they gone from A to B? So I normally like to put at least 2 steps, I guess. It depends on the question, doesn't it? Obviously, I'm just going to add the 5. I think that's the most obvious thing to start with, isn't it? We've got a positive 5 here, so have a look at both and see kind of how you can meet yourself in the middle. And then they've obviously divided by x squared plus 7, so where have they got that? They've also left an x behind. So what they've done is, if you try and kind of piece it together, they've just factorised out an x, which has left them with a bracket of x squared plus 7, and then they've obviously then divided by that bracket. So yeah, you're just figuring out literally how do they rearrange it. That's literally it. Yeah, rearrange the single x, exactly. So yeah, that's already 4 marks, and I think that's pretty straightforward. Now, obviously, part C is then the actual iteration bit. So we've got, starting with x, 0 is 1. Obviously, they have to give you a starting value. Use the iteration formula. X n plus 1 is equal to 5 over xn squared plus 7. You see how that's the same formula? They've just added in these n bits. Exactly the exact same equation as the previous question, isn't it? They've said to do it 3 times to find an estimate for the solution of the equation. Okay, so the first one, I would probably write it down just so that they can see that I know what I'm doing, you know? So write down the whole equation. The xn is the previous answer, isn't it? So like that would be 0 in order to find 1. And then the xn plus 1 is then the next one, if that makes sense. So you think about it like a sequence. To find the next answer in the sequence, or the next value in the sequence, I need to take the previous answer and sub it in. Yeah. So that would be, in this case, because the previous answer was 1 squared plus 7, I'd write that down just so that they can see that I was, you know, I knew that I had to substitute it in. The way I set it up on my calculator, though, is whatever their starting value is, just put that in. So equals. Now it's now saved in my answer, isn't it? Get rid of that. Type in the equation, so 5 over, whenever it says xn, that's where you put your answer. So don't forget that it is squared plus 7. Because now if I press equals, it will give me every time the next value. So that one's 0.625. Now they've asked me to do it 3 times, so obviously that's x2 and x3. I don't think you'd have to write out the whole thing again. I would probably just write it once, you know, the equation. And then from there, I just tend to write down all the decimals, to be honest. 0.67653. Just write them all. because what have you got to lose? 27696, 27696, and then just do it once more for x3. 0.67044. I think it was 8. That's not a 3. 83001. Yeah, and then now, because this one has asked you to find an estimate, one answer, isn't it? Do you see how there's only one dotted line? Sometimes they give you the dotted lines for x1, x2, x3. You write down all your answers. In this case, they've only asked for one. So you would use your final estimate, because technically the more times you press equals, the closer you get to the actual answer, isn't it? So I would just write down the final one. They haven't said how to round it, so I, again, would just write down all the decimals. They've said that they want at least, obviously, 2 decimals. At least 2. But I'd probably go with like 4 or 5, if not just write all of them. Because, again, it's not that hard to write all of them down, is it? Okay. If it doesn't give you the amount of times to do it, it will always give you the amount of times. Normally it's 2 or 3, but it will always give you the amount of times. Unless it's the one where they want you to, sometimes they ask you to focus on the answer, and you just keep pressing until you get that answer. But normally it's 2 or 3 times, yeah. Yeah, this is higher tier, by the way. I mean, if you look at it and you don't recognize the topics, then you'll know it's higher tier as well. So that's iteration. Now, obviously, you can see we're getting into the harder ones. I think we've got 2 more questions, basically. So, question 21. The time period t seconds of a simple pendulum of length L is given by the formula t is equal to 2 pi square root L over g. So, quite a complicated formula as well. Katie uses a simple pendulum in an experiment to find an estimate for the value of g. Now, that's the key thing, because you see how t is currently the subject, but they are asking us for g. Here are her results. So they've obviously given us L, which is 52.0, correct to 3 significant figures. They've also then given us T, which is 1.45, correct to 3 significant figures as well. Work out the upper bound and the lower bound for the value of G. And for some reason, they've said to use pi as 3.142. I don't really know why, because it is a calculator question. So I don't know. But yeah, technically, they've asked us to use pi as that number. Now, this one is obviously upper and lower bounds, but it's more complicated because you have to start by rearranging the equation. So it's kind of like 2 in 1. You have to rearrange the equation to get g as your subject, and then you can start doing upper and lower bounds. And this one was actually I felt like it was a little bit tricky to rearrange, actually, this one. So let's start with that. I'm just going to rewrite it over here. So we want to get g on its own. So what I was thinking is, what I did was I divided by the 2 pi to start with. 2 pi, and you've got the square root of L over G, and then I squared both sides. So squaring this fraction, you get t squared, you get 4, but you also get pi squared, and then you just get L over G. But the problem is that G is in the denominator, isn't it? So what I would do is I would cross multiply like that, or maybe even just multiply by 1, I guess. Let's just move the G, shall we? Let's just thinking. No, let's cross multiply. Doubt myself now. Cross multiply. When I say that, I just mean multiply it across by both denominators. You can do that in 2 steps if you want, or just in 1. So when I multiply by G, I get that, or you could put it the other way around, it's fine. And then when I multiply across by 4 pi squared, I get this. Now I want to get G on its own, so all I need to do is divide by T. T squared even. Don't forget the squares. Squared. There we go. Yeah, rearrange it first. Yeah, exactly, t squared. So there's all of that first, which I'd imagine it's only 4 marks the whole question, so that's probably only 1 mark just to rearrange it, which is kind of annoying. But anyway, I feel like it's probably only 1 mark for that. So let me just get rid of this because we're going to need some space for our upper and lower bounds. and I'll rewrite it up here. So g is 4 pi squared, that's meant to be an L, there we go, over t squared. So they've asked us for the upper and the lower bound for the value of g, so we need both. We need to figure out what do we need. Because we're working out both the upper and lower bound, we're basically going to work out the upper and lower bounds of the original numbers anyway, aren't we? So you can work that out. So L, the upper bound. They've done this one deliberately because I think this one's a little bit harder to figure out the upper and lower bounds for, because I feel like naturally you might want to put 52.2, but it's not. We're including the 0, and as I said, you add half, when I said about error intervals, you add half of whatever it is. So the third significant figure is this one. What's half of that? 0.05. So that would be 52.05 for the upper bound. Then the lower bound, you just take that away, take away 0.05, so 51.95. I feel like we'd want to put 51.5, but it's not. 51.95. And then for T, that one's a little bit more straightforward. I guess maybe confusing just because there's loads of 4s and 5s in that one, but it's not as difficult. So let's not let me write it. The upper bound is 1.455. You just chuck on another 0.005, I guess, in that case. And then lower bound 1.445. Yeah, I guess it's confusing because there's a mixture of 4s and 5s, isn't there? If it says consider bounds and work out the value to a suitable degree of accuracy, do you do the upper or lower bound? When it says by considering bounds, work out the value, so they only want one answer, you have to work out both. You have to work out both the upper bound and the lower bound, and then when you've got your two answers, you then look at both of them and you try and find something that they would both round to. So that's what they mean by rounding to a suitable degree of accuracy. You look at both of them, they will normally both round to the same number. Maybe it's the same whole number, maybe it's the same one decimal place. It depends on the numbers, right? But they will normally both round to something in the middle. And then you'd say, oh, because they both rounded to this. That's your reason at the end. Because they both rounded to whatever you chose. So there we are, we've got L and T. Now, this is then, I guess, the bit that's confusing. Let's do the upper bound of G first. To get the biggest possible value of G, because we've got a divide, when it's divided, it's always one of each, isn't it? A mixture of upper and lower bounds. So obviously the 4 pi squared is going to still be there anyway. And then L, to get my biggest possible answer, I want the biggest possible numerator. So that would be my upper bound for L. And then obviously then divided by the lower bound of T, divided by the smallest possible value. Don't forget that that is squared though. That is squared. Four pi. And the pi is also squared. Oh, actually, because they said to use 3.14, didn't they? In the mark scheme, they don't mark you down if you just use the pi button. That they still give you that. That's still fine. 3.142. Yeah, I don't know why they've asked that. I guess, yeah, it doesn't even make any sense. But anyway, yeah, technically, we have to use 3.142. So I'll just do that. 1.45 there, squared. We get 984.3677 loads of decimals. I'll just write down a few. 984.4.36. Was that right? 7, something like that. Yeah. If it was closer to 0, I'd put more decimals, but because it's already like 900, I'm only putting a couple of decimals. And then we want to swap it, don't we? We want the smallest possible value of G. So that's just then the literal opposite. I want the smallest numerator, so the lower bound of L over the biggest denominator, so the upper bound of T, and again, that is squared. And then I'm just going to go back. I'm not even going to rewrite it. Just go back, change the numbers. You don't have to rewrite the whole thing. Obviously, make sure you have changed it correctly, though. Yes, that looks fine. So then we get 969.018. Now, this one, they haven't asked us to, they haven't done by considering bounds, because if you look, neither of them round to the same thing. As in, if you were thinking like, one would round to maybe 980, one would round to 970. That's why they've not done by considering bounds in this case. But if they had, normally, let's say that one was that and the second one was 975, you could say, oh, they both round to 980. That's what, if it was by considering bounds. Obviously, this one's not because you can't round them both to the same thing. So yeah, they haven't said how to round it. So again, I'll just leave a few decimals. Always leave more decimals than you think you need is what I would suggest. So yeah, more of a tricky question, but 4 marks. And obviously question 21, this was very close to the end. Let's see, just having a look at the comments. So for T is the accuracy limit, then you divide by 2. For T, yes, because you're looking at the third significant figure, which is this one, which is then technically 0.01, isn't it, if you think about the digits, and then you half that, so you add half of that, take away half of that, exactly. Yep, you're right. Just checking any more. Yeah, I think this should have been a 5-mark question, to be honest. I think this was quite a harsh marking question, this one. How did I get the lower bound for L? Because sometimes if you find it hard to visualize it, because I think significant figures is quite hard to figure out, sometimes I like to use a number line, right? So put the actual number there, and then you look at what it's rounded to, 3 significant figures. So we're focusing on this one, aren't we? The 0 is the third significant figure. Do whatever it is, 1 above. So that would be 1 significant figure above. Then you do 1 below, which is not that, which is 51.9. This isn't the upper and lower bound, obviously. And then the upper and lower bounds are halfway. Sometimes I visualize it like that. So obviously the lower bound is then 51.95 and the upper bound is 52.05. You can always lay it out like that if you like. That's what I tend to do normally. There just wasn't that much space in this one. Yeah. Do you do more past papers or individual topics? It depends on the person. Hopefully, I don't know if you've done past papers and there's been topics that you keep getting wrong. If there are, then maybe have a look at those. If not, then just keep practicing past papers. Just if you want general revision. Yeah. Okay, the last one that I have prepared is obviously some kind of more advanced trigonometry, right? Sine rule, cosine rule, that kind of thing. So we've got question 17. This is actually a 5-marker now. The area of triangle ADC is 56 meters squared, 56. So ADC is the bottom one, right? So only the bottom one. Work out the length of AB. So this is, again, one that's got a bit of everything in. I think we've got all of the formulas for advanced trig in this. So we're going to have to start again with this. We might as well start here, mightn't we? Think about the formula. Not in pink, preferably. The formula for the area of a triangle. This is one where when you were asking, I don't know if you're still here, but the person who was asking about how do you know when it's trigonometric area of a triangle and when it's just normal base times height over 2. This can't be base times height over 2 because you don't have a height. Like there's no perpendicular height, is there? You also technically don't have the base. The base would have to be AC. So I couldn't use that. I have to use the trig one, which is a half AB sine C. Now I know in this case the letters don't match up. If you want to, you can always cross out the letters and change it. That goes for sine rule and cosine rule as well to make it match your formula. But I feel like the area one's not that hard. I know that the area is 56, and now let's sub in some values. So A and B are the two sides surrounding the angle. The only angle I have for ADC is 105, isn't it? So A and B have to be 11. I should give myself some more space. Half times 11, but I don't know. So let's call that one C. We'll call this one B for now, right? We don't know that side. It has to be the two sides that surround the angle. So I'll just leave that as, you can leave it as B, you can leave it as X, you can leave it as, let's leave it as CD, shall we? Because that's exactly what it is. And then sine of the angle, which is the 105, because I don't really have any other angles, do I? There. Now that I've set up that equation, do you see how the only thing is that I've got CD missing? So I just need to rearrange this. Again, a lot of kind of rearranging questions. Again, you can do it in more than one step. You can do it all in one step. I'll probably do this one just all in one step. divided by everything that I want to move across. I want to move the half across, I want to move the 11 across, and I want to move the sine 105 across. You can do it all in one step, as I said, or you can do it separately. It's up to you. But that immediately gives me CD is 10.54 because I just did it in one step. 10.54, obviously dot, dot, dot. So that's this one here. Sometimes if you don't know what to do, you might as well set up the equation, and then if there's only one thing missing, then that's the only thing you can really find, isn't it? You might as well just find that. So I've got this one now. Oh, it's meters, isn't it? Meters. Now, obviously my end goal is this side here. So I still don't have enough information about triangle ABC, so still working with triangle ADC. What can I work out that would help me with triangle ABC? Well, normally it's the line in the middle, isn't it? The one they share. So AC. So I want to work out AC. How do I do that? Well, just looking at the information I've got. I want to find AC. I've got two other sides and an angle. That to me screams cosine rule. You've got an angle and the sides around it, and then you want the other angle across. So that to me is cosine rule. Obviously that's on your formula sheet. I'll write it here. Because we're trying to find a side, it is in the format that we want, isn't it? A squared equals b squared plus c squared minus 2bc cosine A. Again, you could, if you want to match up the angles, call that one A. We could leave C as it is and call that one B again. This is side A. If you want to do that, you can rearrange the letters to make it match your formula. So to find AC squared, I would need to do, it doesn't really matter which order you add them in, but I'll do it technically in the correct order. The 10.54 I've just worked out squared plus 11 squared minus 2 of them preferably. 2 times 10.54 times, you see that? Yeah, just about 11, put cos here. Cos of the same angle. This time obviously now we're using cos, so don't forget to use cos instead. And then you just type all that in. Now I still have my answer as 10.54, so I'm going to use the whole of the decimals again. I'm trying not to round anything too soon if I can avoid it. 11 times cos, not sine, cos this time, of 105. Now do remember though, this is AC squared. You can see it doesn't really make sense. If you look at all the sides, you've got 11 meters, 10 meters. It's not going to be 292 meters. So don't forget to divide, or well, to square root it, right? Don't forget to square root and just copy your answer again. So AC is about 17.09. Again, I'll keep my decimals in the calculator, but just write down a couple. So now I know this one. Finally, I have enough information about my top triangle, don't I? And then I have to figure out, okay, I want to find a side. I've got one other side, so that's 2 sides, and I've got 2 angles. That to me then screams sine rule. Just make sure though that they obviously are the opposite sides and angles, isn't it? So for example, yes, the 17 meters is opposite the 118, which is perfect. And also, yes, the side that I want to find out is opposite the other angle, 48. So that is perfect, sine rule. Because we're looking for a side with sine rule, we always put the sides at the top. If you're looking for an angle with sine rule, you just put the angles at the top, as in with, obviously with sine. So just flip the fraction upside down depending on what you're looking for. I'm looking for a side, so I'll put AB over, it has to be the one opposite, so sine of the angle 48. And then my 17.09, obviously put both sides at the top, is opposite sine of the angle 118. Now you do have to rearrange that, don't you? So just multiply across by this denominator to get AB as your subject. And then we're just left to type it in. Sine 48. So it's just a lot of typing in basically, isn't it? A lot of substitution. So I've still got my answer here. Again, I'm still going to use the answer button to copy that just so I can get as accurate an answer as I can at the end. Sine 118 times sine 48 there, and then we get 14.3856. Now I can finally round it because it is the answer, right? Now I'm going to round it. I try not to round anything too soon. So for one decimal place, 14.4. There we go. And that's at least shown you a bit of everything. We've got the trigonometric area of a triangle at the top, we've got cosine rule, and then we've got sine rule. So at least we've got all in one in that question. Let me just have a look at the comments. Yes, this is Edexcel. Hard distance, speed, distance, time. Just having a read through. Yeah, okay. Right, so those are the kind of main ones that I had. That's the last of that. I think we could have about 10-15 minutes of Q&A. I could find a couple of questions that you might want to specifically go through, but I've only got about 10 minutes if that's all right with you guys. So if you've got anything that you want to specifically go through, I'll try and find an Edexcel question on that topic if you've got something specific. You said hard speed, distance, time. Yeah, I'm thinking hard distance, speed, distance, time, because that hasn't come up yet. And speed, distance, time, I feel like comes up loads, doesn't it? Functions came up in paper 1, so I don't know if they'd repeat it. Circle theorems definitely feel like I would come up in paper 2 or 3, yeah. Okay. Just bear with me a second, I have to just grab my charger, otherwise it's all gonna crash. But yeah, send it in the comments and I'll choose a few that we can go through for the next 10 minutes. Right, there we go. Also, there's obviously a lot of videos I've done on some of these anyway. I've done a series of videos on the hardest questions on a few different topics. So you can also have a look at that as well on my channel. Not lives, but like actual videos. So let me have a quick look for the speed, distance, time. Because yeah, I feel like there's a good chance that could come up, isn't there? Speed, distance, time. Let me just flick through some questions. Yeah, it says less likely again because it already came up in paper 1. I'm not saying impossible, right? Not saying impossible, but less likely. Also because thirds, you just put it in the calculator because you'll have a calculator anyway. So yeah, that's why I'm not focusing as much on the ones that have already come up. Yeah, let me see if I can find a harder speed, distance, time. This is higher tier. I have mentioned that before. I don't know the person who's asking if it's higher tier. Also, if you don't recognize the topics, that if you've never seen them before, then you can also assume it's higher tier. There's a question 17, which is also upper and lower bounds mixed together. That's the only one I think I've got. That might be the hardest. It's like 4 marks. Let me see if it will let me copy it. Let's see. Yes, let me paste it. This is from June 2017, paper 3. So it is a calculator question, obviously. Hopefully you can read that. Best quality. So yeah, this is upper and lower bounds as well. So actually 2 birds, 1 stone, I guess. So a train travelled along a track in 110 minutes, correct to the nearest 5 minutes. Jake finds out that the track is 270 kilometers long. He assumes that the track has been measured correct to the nearest 10 kilometers, not meters, kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? We're finding speed, but obviously with upper and lower bounds. Full marks. So you might as well find the upper and lower bounds of the time and of the distance. The other thing to note is they've given you the time in minutes, and obviously to see how the speed is in hours. So you would also have to do that. you'd have to convert that as well. So let's see, the time, the upper bound, so they've said nearest 5 minutes. So whatever you do, you take whatever it's rounded to, you half it. So the nearest 5 minutes, that's like plus or minus 2.5 minutes, 2.5 minutes. That's what we would do. So you would have upper bound would be 112.5 minutes, and the lower bound would be 107 minutes. Well, 107.5 minutes. Obviously, then you might want to convert those into hours before we put them in the calculation. We'll just see which ones we need. And then the distance, 270, the upper bound, so that's to the nearest 10 kilometers. So again, half that, plus or minus 5 kilometers. So that would be, the upper bound would be 275, and the lower bound would be 265. So obviously, speed is distance over time. So you're dividing. So remember, when we divide, we need to mix them, don't we? So what I think is, if you worked out, do we need to work out both? Sometimes you only have to work out one, isn't it? Just thinking. Yeah, let's work out the upper bound of the speed. So upper bound of the speed, because it said could it have been, not always, it's just could, isn't it? So I would say upper bound of the speed. How do we get the biggest possible speed? Well, I need to divide the biggest possible distance by the smallest possible time, don't I? So the biggest distance is 275. Now, as we said, the time we do need to convert into hours. So to convert minutes to hours, we just divide by 60, don't we? So I'm going to use the 107.5, and then at the same time, you could do it separately or at the same time, you can just kind of put that over 60 to make it into hours. So I've kind of thrown that in there as well. 275 divided by 107.5 over 60 to make it into hours. Now, the upper bound, which is the biggest possible speed, the fastest, isn't it, is 153 let's say 5. 153.5, that's okay, not a 5, kilometers per hour. So what we're saying is, if the biggest possible speed is only 153, then the lower bound, or the smallest possible speed, is going to be even less than that, isn't it? So that's why I did the upper bound. I said, well, if the upper bound is above 160, then I can say yes. If it's not, which it's not, then I can say no, it can't be greater than 160, because if the biggest value is not even greater than 160, then the smallest value is not going to be greater than 160, is it? So you therefore say no. This is 4 marks. Can you see here? 4 marks. So yeah, that's the hardest one I think I've found previously. We've got here part B, Jake's assumption was wrong. The track measured correct to the nearest 5 kilometers. Oh yeah, because he was assuming, go back a bit, he was assuming that the track had been measured to the nearest 10 kilometers. It's actually to the nearest 5. Explain how this could affect your decision. Well, think about the upper and the lower bounds, or I guess the upper bound, because that's the one we used. The upper bound would be 272.5, wouldn't it, in that case? 272.5, which is a smaller value at the top. So how would that affect your answer? If you've got a smaller, you can always just test it out as well. If you're not really sure, you can always go, right, well, that would be the new upper bound. Divide by the same thing. If you're not sure, kind of just by figuring out yourself, you can just do the calculation, because it's not really that much time, is it? Just go back and just adjust this, and then you'll see what happens. Hang on. 7 to 0.5. So we had 153 before. Do you see how now we have 152? So that will tell you. Explain how this could affect your decision to part A. Well, it doesn't actually affect our decision, does it? Because the speed would be even less. So it doesn't affect our decision, does it? Because it's still not over 160. Doesn't affect decision. Something like that. You can always test it out, as I said. If you're not sure what would happen, you can always test it out by actually doing the calculation. Yeah, so that's a harder speed, distance, time one. Yeah, how many marks for part A? You can see here. That's the marks, 4 marks. 1 mark for part B, so 5 marks in total. Okay, I don't know if anyone has one more question they want me to go through. If it's something I've done a video on, then I'll link the video instead, but I've got time for one more question. difficult ratios. Ratio, I think my problem with ratio, because I find ratios quite hard. My problem with ratio is it's so random, isn't it? And you'll get loads of questions on ratio. It's not just like once. You'll get so many different varieties of questions. Yeah, I think ratio is quite... I mean, either it's question 3 on the paper and then it's okay, or it's right at the end, isn't it? Which is quite hard. So let me have a look if I can find maybe a harder one. Okay, there's a question 17 there. That's 5 marks. That looks interesting. Just having a little look through. Obviously, there's loads of ratio questions. Now, a lot of them are kind of in the first half of the paper, so not too bad. Maybe that question 17 might be quite good. That one's fine. Yeah, to be fair, actually, now that I look at them all, then most of them are on the first half of the paper at least the ones where it's mostly focused on ratio. Not to say that you can't have ratio within another question, but yeah. Okay, I think I'm gonna go through that question 17. It's 5 marks, so we'll do that. It's quite a big one as well. Let me just see if I can copy it. Lost it now. Oh, there it is. Yeah, actually, it's also a calculated question, so that's quite good. See if it will let me paste it. Half the time it doesn't for some reason. Again. Copy. There we go. That's the one I was looking for. This is 5 marks, this one. And it is a paper 2 question. Get rid of all that. 5 marks. Okay, so we've got P and Q are 2 numbers such that P is bigger than Q. When you subtract 5 from P and subtract 5 from Q, the answers are in the ratio 5:1. When you add 20 to P and add 20 to Q, the answer is in a ratio 5:2. Find the ratio of P to Q. So this one, there's quite a lot of questions actually where you have to know how to convert from an equation into a ratio, or even vice versa actually. Here we've got 2 kind of ratios I could set up. So for the first line, it's obviously 5:1. But if I just write that, subtract 5 from P, so that would be obviously just P minus 5, right? So to translate it into kind of algebra, and then the same Q minus 5 is 5:1. We've then got P plus 20 to Q plus 20 is the same as 5:2. Now from here, even if you just write that, that's 1 mark, right? One of the two, you don't have to write both of them. If you write at least one of those, you get 1 mark. But what we want to do is convert them into an equation now, well, each of them into equations. So there's 2 different ways to convert ratios into equations. It just depends which you prefer. I prefer to think of it as you just multiply like opposite. So for example, this one would be P minus 5 is equal to 5 times Q minus 1. I've not times it by 1 because obviously, well, I've not written that, but I have times it by 1. Makes no difference, does it? And then here I do the same, because it's basically simultaneous equations, I guess, isn't it? 2 brackets P plus 20 is equal to 5 brackets Q plus 20. So just remember that's how you can convert from having these 2 ratios into 1 equation. You can just do it multiply. Some people write them as fractions. That's fine as well, but I don't know. I prefer to look at it like this. Yeah. Yeah, the wording is a lot. That's the problem. Because they want you to translate it from words into algebra, basically, don't they? So I've got 2 equations. If you write that, even just one of those equations, so far that's 2 marks. Then what I would do is, at this point, it's almost not even ratio until the end again, isn't it? At this point, we can just solve to find P and Q because they are simultaneous equations, aren't they? So let's tidy this up a bit, just loads of expanding, simplifying and collecting like terms. That's only 1 mark, unfortunately, but it's not that hard, I guess. Minus 25. Let's see, what do I do? I guess I get the 5s and 25 together. Maybe I'll move the 5 to get P as our subject, I guess. It depends how you want to rearrange it. You can rearrange it however you want. Minus 20. Expand this one. 2P plus 40 is 5Q plus 100. Let me move the 40 over, might as well. 5Q plus 60. Okay, you can either do elimination or substitution because they're both linear. I'm just going to substitute it in. Normally I do elimination, but I'm going to do substitution just because it's kind of fallen that way. I've got P as the subject, so I might as well substitute it in. So that's the only reason, but you can do either method. That's meant to be a minus. So 2 times 5Q minus 20 is 5Q plus 60. Expand it. 10Q minus 40 is 5Q plus 60. Now I've just got an equation with Q, so I can solve that. 5Q is equal to 100. Q is 20. And then once you found one of them, I'm just going to substitute Q back into this one because obviously P is the subject, so that's a bit easier, isn't it? 5 times 20 is 100 minus 20, P is 80. Okay, so I've got my values for Q and P. Now the thing is, they said find a ratio for P to Q, give your answer in its simplest form. So I just need to write those values next to each other. Remember, it's P first and then Q. 80 to 20, but obviously that then simplifies. You can just divide both by 20, can't you? 4 to 1. This is 5 marks, exactly. Yeah, this is a 5-mark question. So you've got simultaneous equations as well as ratio. But yeah, it's the key to this one, and to actually quite a lot in Edexcel I've seen. A lot of the ratio questions you get towards the end is knowing how to set up, obviously, well, the first bit's just translating into ratios, but knowing how to go from 2 ratios where you've got some with letters, some with numbers, and then putting it into the correct equation. That's the bit. Once you've memorized how to do that, you just multiply it, opposite like that, then it's not as hard, really. Yeah. But if you don't know that first step, then it's quite hard because you're like, well, where do I go from here? I'm only going to get 1 mark if you don't know how to go from the 2 ratios separately into one equation together. So yeah, that's probably quite a good one to know. And I've done my own predicted paper. One of the questions in there is, I say similar to this vaguely. It's only 1 equation. It's not 2 equations, but it's like, here's a ratio with algebra. Here's a ratio with just numbers. You have to solve it. You have to find out what x is. So yeah, in my predicted past paper, something kind of similar. The same logic, at least, of going from ratios into equations. So that's pretty quite good. Why do I cross multiply? Do you mean here, the pink bit, or do you mean, yeah, that was it, right? That was the only place I cross multiplied. Just because to be honest, just because I know I have to. I just memorized it, honestly. Some other people like to memorize it as, I'll show you. Oh, why are we going on to this? Get rid of that. That's how I like to translate it. Some people also like to go, oh, I'll just put them, the first ratio, divide it, is equal to the second ratio divided. Some people like to translate it from ratios into equations like this, which is also correct, that's fine, but then you'd have to still end up going through the whole process. So I kind of just memorize that, oh, I just have to cross multiply it. That's just, when you've got 2 ratios, one that's obviously algebraic, one that's equivalent but numbers, you just cross multiply them to create an equation. I just memorize that, if that makes sense. But you could, I'll put or, you could translate it like this if you want. It's whichever makes more sense to you. If you do this, that's fine, but you're still going to have to then start cross multiplying anyway, aren't you? If you think about it, you're still going to have to do this, aren't you, to solve it? So yeah, it's up to you, but as long as you know how to go, and I keep saying this, from 2 ratios, one that's algebraic, one that's just numbers, into a single equation, then that's quite an important method, I think. Yeah, you got to decide whichever you think is easier. It doesn't matter. I think the cross multiplying is easier. That makes sense for me. Some people might find it harder to remember that it's a cross multiply. Obviously, don't multiply these 2, right? That's not the same thing. Some people might think it's harder to remember to cross multiply, so they would just rather go one on top of the other and then it matches perfectly. That's fine. If the fraction one makes more sense to you, do that one. If the cross multiply one makes more sense to you, do that one. They're both equally correct. It's just different formats, isn't it? They're both equally correct, as long as you obviously apply it correctly, right? So that's up to you, whichever of those you want to use. But it will work for any of those types of questions. Is this AQ8? No, this is Edexcel. Yeah. Yeah, this is Edexcel. All right, guys, I have to leave the stream here because I do have my own tutoring sessions I need to do today, unfortunately. Otherwise, I would have just carried on tonight. But yeah, I have to leave it here. So thanks for joining me in this last stream before your paper tomorrow. As I said, I have posted my predicted paper for paper 2 if you want to have a look at that, if you want to do some kind of more work tonight. It's up as a video, and it's, if you go to that video, in the description is the download for the actual the PDF. If you want to have a look at that, that's up to you. If you want to look at harder questions, have a look through my channel. I've got kind of Edexcel hardest questions, I've got Edexcel most repeated questions, which could be, you know, could be paper 2, could be paper 3, doesn't really matter. So yeah, have a look at the kind of videos, not the lives necessarily, but the actual videos I've uploaded. Hopefully some of those will be helpful for your revision tonight anyway. And we will carry on probably on Thursday. I think tomorrow you probably won't really want to be revising maths tomorrow night. So probably on Thursday we'll carry on with our live past paper walkthroughs anyway for higher tier. But otherwise, best of luck. Please let me know how you went on tomorrow. I hope it goes really well. I hope it's better than paper 1. Try not to panic when you're in the exam. If you feel like you've read question 1 and you're already panicking, try not to panic. Just try as hard as you can to stay relaxed. And just, my best advice is to write down as much as you possibly can, even if you think it's not even right. I don't really care. Just write down anything. Try not to leave anything blank. Even if you're just purely guessing, just think, well, what does the subject relate to, the topic, the question relate to? Let me just write anything I know about that topic or those mixture of topics. Just write something down. And then at least they've got something to try and mark, haven't they? You just don't know where you're going to get extra marks from. So try not to leave anything blank. That's my kind of best advice. Otherwise, I'm sure you guys will be absolutely fine, and then you only have 1 more week until the last maths exam. So that's something to look forward to at least. So yeah, best of luck. Thanks for coming and joining tonight, and I'll see you in a few days.